In this example, we will be evaluating the limit of a summation. And so there are two steps to do this, and I'm going to put these over here on the right side of the screen. And they are evaluate the sum first, and the second step is to evaluate the limit. So we have to have those limit techniques, limits at infinity techniques come back and help us out here. So the first thing that I need to do in order to evaluate the sum is to get rid of this product. And when you do that, that'll look something like this. The limit as n approaches infinity of the sum as I goes from 1 to n of 108 over n squared minus, I minus 6 over n. And then the next step is to use the separation techniques for the sum and difference rule and the constant multiple rule to separate all this out into two different sums like this. So we use the sum and difference rule here to have the sum of one expression turn into the sum of two expressions, and then we common factor it out or use the constant multiple rule to get the 108 over n squared to the front. And I left the constant inside this sum so that we can now use the summation formulas for I and a constant to get this. Remember, the summation for I from 1 to n is n times n plus 1 over 2, and the summation of a constant is the constant times the upper bound. So I'm going to highlight these in some different colors here to make sure you understand where everything is coming from. There we go. The next step in simplifying the sum, we're not ready to take the limit yet, is to reduce an n in the numerator here with an n in the denominator and reduce 108 over 2 to 54 over 1. And this leaves us with the limit as n approaches infinity of 54 times n plus 1 all over n minus 6. So we're trying to take the limit of all of this. The next part of this limit at infinity, well, the limit at any value, the limit as n goes to any value of a constant is just a constant. So we really only need to work on computing this limit right here. So we know that the limit will also be equal to 54 n plus 54 over n minus 6. Now with this first term, we can divide each term by n in the top and the bottom. And that is a completely legal thing to do. And that limit will turn into something that looks like this. We will have the limit as n approaches infinity of 54, because these n's, right, if we divide each term by n divided by n cancels out. But the next part will be plus 54 over n, and the denominator will be 1 minus 6. And then recall we had this rule, I'm going to put it right above in blue here, that the limit as n approaches infinity of anything over n to any power goes to 0. So that means this part goes to 0. And again, the limit of a constant is just a constant. So this limit turns into 54 minus 6, which is equal to 48. So the first thing we did, a lot of work finding the sum and simplifying what the sum was. When you get into the limit portion of this exercise, you can look at each term individually. So we divided the top and bottom here by the biggest power of n in the bottom. to get this expression, and we know that if a term has an n in the denominator, that will be 0. So we were just left with 54 minus 6 left over, and when you subtract those, you get an answer of 48.